So we'll move on to the next radio in this box from the same person in Yorkshire, Audioline 345, which I understand has also had the 80 channel illegal modification kiss of death. Not supposed to be slotted screws. I might be able to address that because we've got the right ones in stock. Let's hope the phase lock loop chip isn't removed, or this has no hope. I've had a firm in Brazil say they can supply the TC9119 and they work out about £25 each, and I have to buy 100. So I know that I'm not going to sell 100 TC9119s at even £25, let alone a handling charge. So there we go. I can't say I've ever known the chip to fail on its own. It's always been a set that's been messed with and has been killed. Now I've also got a Uniden 300 coming for repair. We'll probably do that straight after that, even though it's not that radio's turn, but it's quicker to do sets that way when similar sets have come in. So here we go. Yeah, it's had the kiss of death, alright. Alright. Now, in contrast to that Midland set, this is what you'd expect for 30 years use. It's dirty. Lucian Charlie CB 01403 864 912. I hope it's not them who did this naughty modification. So we'll switch the smouldering bat on. Not sure what that does. It's connected to the PA switch. And that's connected to the PA switch. So is this to compensate that these things are never on frequency? That's another ball to put in the microwave to destroy. One wire gone. Two wires not quite gone. Take that off. We'll cut that off. Then we've got to try and work out what they've done. So that's connected to power by the looks of it, yeah. An SC2T Mark II. Good. What's worse is people would actually have paid to have this done. So once we've got rid of this, we can then start wondering what's wrong with the radio, because this will have killed it. So we've got a screened lead going there. I'm going to have to take the screws out of the bottom. Anyway, I'll pause the video for now. You can see the gist. Just to make matters worse, as I go underneath it, we've got a Roger bleep board as well. So that's going to come out too. If we know where the wires go. Probably better leave that in for now. No, stop it. Out it comes. So there'll be no transmitted audio with this missing. So that's something to sort out later. I'll cut that wire. It needs to go around the other side. So what does this sound the back of it? No idea. 4001. More junk. Right, we'll go and find out what they've cut. So as we get into the swing of this and try and restore things, capacitor 60 is missing. So it looks like it's across the crystal. So we'll look at the realistic TRC 2000 and capacitor 60 is over the page. It's 39 picofarads and it's a disc ceramic. 39, which is that's it then. Let's see if we've got one of those. This is a limited selection of high quality ones, and then we've got a normal disc ceramic box of capacitors. It looks like we'll use that one. Yeah, 39. I've had these in stock about 10 years, so just clean the leads. Just make sure that says 39 on it. It does. So I've somehow got to get that in there. We'll solder one lead with the red on its side. I'll solder the one which still has some print, and the one that we're going to have to bend across to where the tracks come away. That's that. And it goes across to there. We'll just check with our Uniden 200 or whatever it is. slightly different board, different part number. So we've got, yeah, that goes straight across. There we go. So we've not got everything in. We know there's going to be no transmitted audio because of me taking the Roger bleep board out. But apart from that, we should have enough bits in to make it work. So like we did with the Midland, we'll run it on the power supply instead of off its mains power supply. So we can go in on the, or go on in the, on the connector at the back. So that's actually easier. So taped across that switch. So we'll just break through the tape to do that. Right, we'll power it up. Start at 9 volts. And we're lit up. It's dirt on the channel change. So yeah, there's no short. We're drawing 170 milliamps. So we'll go over to 13.8 volts at 1.6 amps. And there we are, lit up. Well, we were, but of course I tilted it backwards and knocked my negative lead out. So that's going to be the disadvantage. Right, so I'll connect it up to the test equipment. Now I know there's capacitors to change on this. The fact the display's on tells me the usual culprit hasn't yet failed. So I'll put the signal generator on 2779125. Don't need picture in picture on at the moment. Yes, oh, there we go. 79125. We'll turn the wick up on that and make sure we've got RF gain up, and we'll plug a mic in. So gets the Comtron mic by mistake. So we've got no transmit, no receive. Goes into transmit, no, it doesn't even go into transmit. So clearly the phase lock loop isn't running. So we're going to have to start the diagnosis. Okay, it's the next day, it's Sunday, and I was poring over this yesterday to try and see something which I probably missed in what silliness had done. And I went to church this morning and played the organ at Welby, and I came back and I saw it straight away, and there we are. The other thing I've had to do is to look at that scrap chassis I've got to see what was missing from the microphone socket. The orange wire was disconnected, and I now have it going into transmit, which I didn't have before. So having got what I've done linked back how it should be, we do now have rudimentary transmit and receive, or we did. Have we gone off frequency? Yeah. Signal generator's got clonked. Right, so that's 2779125. I've sprayed the controls, it sounds awful. And transmit, we've got, I'll go into picture in picture, and we should have transmit. And it's doing 500 milliwatts. The high-low power makes no difference because it's been rewired. So that orange wire is probably why we haven't got high-low power. So why would they do that? Let's modify it so it's always low power. Now I don't know which switch is high-low power on here. Oh dear. Don't have any fronts, do I? So we've got a joined wire there. This is what I don't think we're going to be doing the PA function on this. I'd have to dismantle another set. Where's that pink wire go? There. Is it me knocking the power off? Yeah, that's okay. So I've put the 4 capacitors in that always need changing. So I've just changed that and that, the 2 470 microfarad ones. I've changed that and that. So what we'll just do, I'm going to do a tune-up. It's going to be a flawed tune-up in. That's the wrong tester, in low power, and then we'll take it from there. Where on earth is the meter gone? Anyway, at least it proves the synthesizer chip's still working, which was concerning me because of them being virtually irreplaceable. Right, well that's what's left of 220 microfarads, so that was knackered. So it's hanging on by the skin of its teeth. This should be 470. 136. So that was hanging on by the skin of its teeth. Have we got any more, or did I get them? Oh, there's one. They've been replaced with Nikon ones. Should be 220, and it's 29, so that's knackered. But these are the 4 usual culprits. I think the other one must have fallen on the floor. The mice can eat that, and that's why we changed those capacitors on site. So I'm still working on my external power supply, then I can monitor the current drawn. So we need to do the VCO first. So I'll put the meter right in the middle of the works, like any normal person would. We'll have an earth there from there. It's resistor 54. Alright, we'll have an earth from there. Resistor 54, which is the resistor after those 2 capacitors. So the first thing we're going to have to do is to go into transmit. They do it on channel 40. So channel 40 into transmit. Believe it or not, it is transmitting. And it should be 3.5 volts, and it's 5.7. So we'll unseal what they've sealed. Difficult having, I need an extra hand really. Play the organ better, wouldn't I, if I could have an extra hand. .5, that'll do me. And then into receive. Seal that back up. Into receive is the next coil along. Punching it at the same place. 3.5. And I've already turned this coil. Hang on a minute, am I in the wrong one? I've already turned that coil the other way around because it was broken. L18. Yeah, that's L18. Oh, it's test point 3, that's where I'm getting nowhere. And it's channel 20 you do it on. So let's go looking for test point 3. So test point 1, resistor 52. Test point 2. Test point 3, resistor 6. By the looks of it. Which is there. Let's see how many of these I don't see. Right, we'll get the oscilloscope out. Again, I'll use the portable one because I don't want to change the two which are on the instrument stack. Right, what are we doing? Connect the oscilloscope to test point 3, adjust for maximum on the oscilloscope. Try and get that into best shot. So it's L18. Well, it was L18. That's really all the way down, to be honest. Let's just see if it's not on a false point. I think everything's so nicotined up in this. This would have been a candidate for my dishwasher. Nearly at the bottom. Right, so that's that done. Touch that off. So we'll have a look at the performance. I'll plug the test equipment in. So we're now going through the test gear. Making sure mic gain and RF gain are at full. Oh, tone actually works. So we'll have a look at what the cyanide meter's got to say for itself. Just go over to that. So if we adjust the signal on the signal generator, which is currently 100 microvolts, for our 12 dB point, this radio is currently doing 2.5 microvolts. I'm hoping it comes up better than that. We'll write it on the back of this hymn. Jesus the water of life has given. Alright. So this is 345 and at the moment we've got TX, deviation, frequency I can't adjust on this chassis, and let's have a look at synad, and it's 2.5 for 12 dB. Now we'll go back to transmitter. Now we've done some rudimentary setting. So go back to the main meter. It's drawing 300 milliwatts. They do receiver first, which is absolutely bizarre and ridiculous. So they want you to do what? 16, 15, 13, 12, 10. I can't even see where 16 is. Yeah, 16, 15, 14, 13, 12, 10. This is why on the Cybernet chassis, this one, which is receive on there, it's transmit on UDN, so people who aren't that, or not following a service manual, will inadvertently adjust that. This is why we get, I think, them coming in a bit dodgy. So, oh, I think it is on full power, it's just not set up right. It's now doing 1 watt. I'm just going to make sure we're not actually inadvertently on low power by finding the preset for low power. It's VR4, and of course this board's so filthy. It's that one is low power. So just make sure we're not on that. No, we're not. I just, you know, it just could have been that they'd connected up low power as the permanent one. So for some reason they've got this only doing 1.2 watts. Need a bigger tool for that. Two watts. Two and a half watts. Just make sure we're not on a false point. No, we're not on a false point. Go through these again. So these are all interactive, so I've just got to go backwards and forwards. Just a whisker away from 3 watts now. Make sure none of these coils have been stretched or compressed for that matter. Right, so that's what it's doing. It's doing 3 watts. I would think the only way of increasing that is to either change the output or the driver transistor or both. So it's a bit like a brand new set, isn't it? They're about that kind of power. Not that it makes any difference, to be honest. We'll see what it does on its own power supply anyway. So that's VR3. So we want the meter to read. I'm not going to be able to tilt this up because I'm going to knock my power lead out. It's actually reading dead on the 4, which is the psychological where it is. Deviation, let's have a look at that. Wallow. Bearing in mind I haven't altered this, why have they got that so low at 1.7? You know, none of this has been altered. None of the frequency control's been messed with, but none of these adjustments which I'm doing have been messed with. So it was doing half a watt and 1.7 deviation. What a 10-1 radio. Is my aerial in properly? Yeah. The frequency is 27, I'll show you that. 27,79143, so it's still slightly high, which is fine. There's nothing I can do about that. It's just a fixed crystal with no means of adjustment. So we'll get the deviation up, and I forget my little cord thingy out, the chromatic tuner. And it's VR5. Which helpfully says deviation on it. Set that for 2 and then we'll just do a whistle. Wallow. That's actually spot on, 2.2 to 2.5. So just make a note on here that it was 500 milliwatts and that's now 3 watts. Deviation was 1.7 kilohertz. It's now 2.2 to 2.5. That's correct. Frequency 27,79144. Right, so let's have a look at what the receiver's doing, because that really does need to come up. So I'm going to put an S9 signal on. And we'll get that detector adjusted. So go back a page on the manual, things they want you to do receiver first. And really you need to set the detector first, not like they've said. So it's L19. I think it's that one, but I'll just see on the layout. It is. So with the oscilloscope on, the bench light off, and let's look over at the oscilloscope when it comes on. There we are. It's enough volume for it to be a sensible trace. And adjust L19. And let's hope we get a bit more out of it, because at the moment it sounds a bit nasty. Yeah, to be honest, it was about right. Now then, we'll go over to the synod meter, and let's hope we can get a bit more out of it. So we've got 2.5 microvolts to beat, so we'll get the attenuator adjusted so that that's round about 4 dB, and they want you to go that way, I'm going this way. So that was already spot on. You know what, this must have been dreadful on EU channels when it had that illegal modification to do that. Because it's never been retuned, has it? Now these are nothing like as sensitive as Cybernet radios, which is probably why they are better for bleed over. There's a bigger signal one on for that. And that. Check it with a small signal. Go back to a bigger signal. Doing 1.8 microvolts. See whether anything can be got further. Yes, it can. So they are interactive, these, so you've just got to persevere. It's not the factory where they just had a big needle which you had to turn it to. So now we're at 1.8 microvolts. Look at the other scale. No, we're nowhere near. So what can you hear down to? To be honest, can't hear beyond 0.85. So one of the things I'm not liking about this is the RF gain is very vicious. So if I put that level of signal on, turn picture in picture off, you don't need to see anything. And then I just touch the RF gain, it's gone. I just wonder if it's dirty. Just spray that. So I'm just making sure nothing's happened underneath. like with the aerial connector, and no, it hasn't. I think in view of the capacitors which we've taken out, and they've all been very sad, this could well be one which would benefit from a recap, because you only need a bit of leakage in the receive, it's not going to be any worse, is it, for it? And it's not that expensive. It's about £12.50 worth of parts. So it's not a nice set. This, you know, it's had about. It looks like it's had 40 years of use. And if it was the pristine one, then I'd be first in there to restore the PA function. But I just think that the customer's not going to want to spend that kind of money. We've got to change the power supply capacitors, that's a fact, in view of its age. I think we're going to... They are notorious. What I didn't tell you, which I should have done, is when I changed that 220 microfarad capacitor, which is the most notorious one in the set, it had been changed before, but with an identical one. Now, for that to happen, they must have recovered that out of a scrap set, perhaps a Audioline 340 or a Uniden 100 or a realistic 2000, because it's exactly right. Well, you wouldn't do that. You'd jolly well order one, wouldn't you? You know, it's 220 microfarads at however many volts. I think we put 25 in. So they've gone and replaced a capacitor with a capacitor that's of a known poor kind of standard. So I think the thing to do is to change everything. So I'll set about doing that. Right, I've changed all those capacitors. We have got it down to just about 1 microvolt. So there's our 12 dB. And there's the attenuator 1 and 1, just about. Just a little bit better than that. So that's probably about where we're going to be with that. And the big coil which made a difference when I've just done a quick retune is this coil, which means that capacitor must have been well out of spec. Out of those I changed. It sounds better. So all these ones around the audio amplifier, an improvement. Let's see if we can get anything better on transmit. Oh, I can actually hear. Yeah, I can hear 0.25 of a microvolt now, and before I could hear 0.8, so that's the best I could possibly hear for getting instrument readings, and now I can hear there. So it's made a big difference. Not all sets have gone like this. I think this is huge hours, and some of these capacitors are only going to last 1,000 hours anyway. So let's just look at transmitter. Be fun if we got more than 3 watts out of it now. Well, we get 3 watts. So let's just see. Check that one's not as a false point. No, it's not. So it's doing a good 3 watts now. I'm not showing you the meter. So I've had the transmitter running now, and it's full scale deflection, so it's 3 watts. Disappointing, but that's how it is. Whether or not we can ramp up the power supply to say 14 volts when we do the power supply, might just be able to do that. I don't want to take it beyond that. We've upped the voltage of all these capacitors, So there aren't any 16 volt rated ones anymore, or even 10 volt rated, so I would be able to do that. Because if these output transistors have gone low gain, you know, the customer isn't going to want to be spending like 16 quid on one and 5 quid on the other. Not for a set this tired. Good. Well, at least we've got there. I'll just make sure the meter's not now out of calibration. I'll just check it on transmit. That's all right on transmit, and on receive. I don't think we ever set receive. It's actually pegging the needle. So we need to set that. RF meter is there. Don't think you're going to be able to. This is what's going to happen. I'm going to knock the power off. So that's the meter set. We just need to check the squelch. So with the squelch at full, I want it to open by 100 microvolts. So go to the attenuator. 1, 3, 10, 13, 100 doesn't open, so we need to just do the squelch preset. Is that it is, yes. So that's the most sensitive we can get. It's not opening at 100, it's opening at 250 microvolts. Well, that's alright. I mean, we can't alter that. And these are those same presets I was showing you on another set. They are silver. So if I just clean the top of that, you'll see it's just tarnished. And it doesn't matter at all. But they don't necessarily look nice when they're black. Right, so when does the squelch actually open on most sensitive? So now we'll park the signal generator at 0.3 of a microvolt, put the radio to standby. There we are, and open it at. Oh, hang on, I haven't switched it back on. I'll just check that. Right, switch it back on. 3. So 3 microvolts is the most sensitive I can get it. So again, not as sensitive as I would like. Alright, there we are. So the next thing to do is to check the power supply. So I've changed all the capacitors behind the scenes in the power supply except the big one. So we'll do that one now. I'll disconnect. I'll switch off my power supply. That's all done. There's 3 core mains lead on this, so when we do the pat test, it'll be a different test. Again, I need to look at which way around it came out, and it came out positive towards the front, just in case it's not marked on the board. Positive towards the front. So it's 2200 at 35 volts, and it again is a snap-in type. So I'll see if we've got another one in stock. So the answer is yes, we have got another one in stock. So it's RS7441152, and these are 2200 at 50 volts, and the idea is they're the same diameter as what comes out. Some products have got clips they have to fit in. So it is labelled positive towards me. There we go. Just solder that in. And on this one the pins aren't bent over like they are on the Cybernet one. So before this goes back, I'll go over this board with isopropyl alcohol. That board I already have done. Want to get a roll of what I could call television solder rather than this precision type. Right, let's see what mains plug's on the end of it. It is a shrouded one, so that's absolutely fine. We're going to check it's fitted right. So, check they're tight. They are. Now we need to change the fuse. That's a 13 amp fuse, it needs to be a 3. Right, a 3 amp fuse, nicked off Mr. Chippy's bench. Especially if I could put it in the holder. It makes you wonder what dreadful plug was on the end of this one a few years ago, because that's one of the latest ones which is within the last 20 years. So it's wired. There's no fuse I can see this side of the mains, so the plug side of the mains. So let's have a look. No, it goes straight into the. Is this one that runs all the time? It looks like it is. So let's look at the wiring. So that's from the mains. It's got a red and black wire. It goes through that grommet. That grommet is straight into the mains transformer. This is what I was thinking with the Cybernet. It doesn't, it switches the mains. So this power supply runs all the time the radio is plugged in, and then the power supply is simply switched on, and the output of the power supply is simply switched on and off with the switch on the front panel. So there's no mains on the front panel, it's 12 volts. So that's what I was thinking of when I was saying that of the Midland base, but Cybernet haven't done it like that, they've switched the mains, which is better. Well, in that case, we don't need to switch the radio on to test the power supply. That's a bit safer. So plug it in, and let's see what volts are coming out. Presumably it's the red and black. .8 volts. That's a little bit high, but it might make the radio do the right watts. Turn the picture off, we don't need that, it is off. Good. So with my trim tool in the preset and my test prods on the power supply output, we'll turn it down. Oh, that's up. So the lowest it goes down to is 14.4. So now we'll switch the radio on. Oh, of course we've got to switch at the back to DC. AC, whatever. So 14.8, as I say, it's the lowest it goes. So let's press transmit and see what happens. Go back to picture in picture and we'll select the power meter. So what we're going to do, we'll set the power supply was at nearly 15, which is ridiculous. So I think we'll set it a bit higher. Set it at 14.4. See what that's doing. Yeah, it's a good 3 watts, so I think that's where we'll leave it. But the fact it won't go under 14.1 tells me that it's a bit higher than I expected. In contrast, that Midland one came up one switch on at 11.8. So, there we are, we're done. Let's see what it sounds like on my walkie-talkie. Testing 1 2, testing 1 2, 1 2. Testing 1 2, 1 2, 1 2. Good. Right, so we're done. What I'm now going to do is we're going to put this on one side and we're going to start the next job, which is the Uniden base station. And whilst the Uniden base station is on here, we're going to look at this wiring and we're going to restore low power. If I can restore PA within 10 minutes, I'll do it. If I can't in that kind of time scale, then, well, it's not going to have PA anymore. Because it hasn't had PA since about 1985. But it's annoying when it's lost low power as well. The only one of those switches doing anything is high-low power. So we'll come back to this. So I don't know what order these videos are going to be, but I'm going to have to look at the Uniden to discover what's going on. Okay, so we're back on this set. I did the Uniden in between, Uniden 300. So that's ended up getting published first. I've still, despite taking a good photo of the wiring, where the switch is, it enabled me to put the high-low power switch back, but it didn't. It enabled me to put the right-hand side of the double pole PA switch back, but I couldn't figure out what they'd done on the left-hand side, and they've hacked it about something chronic. I put this white wire. It should be grey. I don't have any grey, so that now joins up to the grey wire which goes there. High-low power, as I say, works. I don't need to show you that working. I've aligned it with the preset there, and we've now got it in public address mode. Volume is operated by the mic gain control, as you'd expect. So we're in PA, there's CB, PA, testing 1 2 3 4 5 5 4 3 2 1. So we have PA function back. That's absolutely fantastic, but I've ended up having to take my own demonstration set apart here to find that out. And again, that's a lot of extra work to dig that out of stores and then take it apart for a function I wasn't asked to fix. So it's now a matter of putting it back together, which I'll now start doing. Right, for the moment of truth, we'll now power it up. Cased up. It's got 1 or 2 Frankenstein screws in the side, which should be the Phillips type of screw, which for some reason look like they've come out of somebody's greenhouse. Anyway, we've only got it in black, so do you have the wrong screws in Phillips, or do you have the right screws but in that? So we're testing on, still on PA. Good. Switch back to CB. Channel 19. 19 a Roger. One 9 a Roger. 19 a Roger. Helps with the mic gains up. Well, there we are, nobody in, all having tea, whatever they do, that's it. So that has been longer in time than the Midland 76900 because of the wiring being hacked out. But at least it's got its PA function back and it's got its high-low power back. So, resurrected from the scrap bin, no doubt. And when you look at the back of it, with that dent there, and that dent there, it's probably come out of a skip. So, thanks for watching. It's been a long video, and we'll do an on-the-air test shortly.